Hello and welcome to this video on draft survey. I'm sure all the deck officers have a very fond memory of hanging down this draft ladder, continuously watching all the draft marks and reading it out to the chief officer. This video is about the calculations which happens at the chief officer's end when you report these draft marks to him. This video is in the memory of late Sri V.R. Venkatesan, fondly known as BRV sir in a marine fraternity. He was a director academics of HIMT group. So we really miss you. The learning objective of this video is basically to assist the candidates appearing for D.G.Shipping Phase 1 competency exams. It will also be helpful for those involved in the actual draft survey calculations on board the ships. After completion of this video, the participants will be able to understand the terms and definitions used in the draft survey, what is the draft survey and its objective, the steps in draft survey to obtain the displacement in salt water, and finally, the various corrections applied once the displacement is obtained. Please note that we will not be going into the details of the principles and the formula derivations, which is beyond the scope of this content. Let's look at the definition. Perpendiculars. We normally use two perpendiculars. One is the aft perpendicular and one is a forward perpendicular. The aft perpendicular is a vertical line which is perpendicular to the keel of the ship, passing through the rudder stalk. This is always a fixed entity in all the ships. This is a point which is taken. The forward perpendicular is a line which is perpendicular to the keel, and the point where it cuts the stem, this water level is basically the summer load line. So at the summer load line, the water plane cuts through the stem at a particular point in the forward, and that point is taken up as a forward perpendicular. What is the reason? What is the objective of this draft survey? It is basically a calculation of the displacement of the vessel or a ship, that is the weight of the ship. It is generally carried out only for bulk carriers, where the quantity cannot be directly measured due to irregular shape and size. The value of the cargo on board or discharged is used for establishing the quantity of the cargo loaded or discharged, to establish the transfer of custody of the cargo loaded on board, or to obtain the quantity of the cargo loaded for the BL figures, and also to cross-check the quantity as shown in the load indicator. Let's look at the various steps of draft surveys from the time when the duty officer reads out the visual drafts till we get the final calculations. As you can see over here, this is a shape of a ship. Aft perpendicular passing through the rudder stalk, the forward perpendicular cutting where the load line, the summer load line is cutting the stem of the ship in the forward. We also have visual draft marks, what you see in the red color. The distance between the perpendicular and the visual draft marks is also noted as A, that is for the forward distance, B for the midship distance, and C for the aft distance. The reason why we don't have the visual draft marks exactly on the perpendicular is, like for example, here in the case of forward. The visual draft marks cannot be put in the forward area because the stem is going too slopey, and there would not be any provisions for putting the draft marks. Same thing with the aft also, because of the flare of the ship, it may not be practical for us to put the draft marks exactly on the aft perpendicular. So the main challenge comes for us is how to convert the visual marks to the perpendicular marks. That is basically what is called as a perpendicular correction for the draft marks. It is a process of shifting the visual drafts to the drafts at the perpendicular. Now to do that, let us first understand what are the various values over here. The red line is a forward perpendicular, the level at which the summer load line water level is cutting through the stem of the ship. The green one is a visual draft mark, and the distance between the forward perpendicular and the forward visual mark is what we call as A. Very similar, the midship mark, this is a midship, as we call it, as a midship perpendicular, and the midship visual. There would be a small distance between them, and that is called as B. And the aft draft marks, the green one, and the red one is a perpendicular, aft perpendicular, and the distance between that is C. Now the values what we have to calculate for finding out this correction, the perpendicular correction, is first of all the visual trim. That is the difference between the aft visual and the forward visual draft marks. That is denoted as TV. Next, we have to find out what is the distance between the visual draft marks. That means we have the distance between these green lines, and that is what is called as LV, or the distance between visual draft marks. We also want to know what are the values of A, B, and C. This will be given in the numericals and can be easily found out reading the numericals carefully. Once we have that in place, then the perpendicular correction is very simple. We have a factor which is TV by TL, which is common for all the draft marks. This TV by TL is then multiplied by A for the forward correction, is multiplied by B for the midship correction, and multiplied by C for the aft correction. So by doing this simple calculation, TV by LB multiplied by the distance between the visual and the perpendicular, we can get the individual perpendicular correction. Now, the value what we get has to be either added or subtracted. So how do we decide on the signage of this? Either we add or subtract. How do we decide a plus sign or a minus sign? Now, what you see over here is a magnified view of the forward of the ship. This is the stem of the ship. This is a forward perpendicular. This is a present water level. And this is a visual draft mark. So basically what is happening, and the ship has got a stern trim. So that is why the water level is going a little bit slopey towards the aft. Now, the value what we have is a visual draft marks, and the value what we want to find out is a draft at the forward perpendicular. So now we have a small correction which comes about. So let us see how to apply this correction and how to apply the signage. The easiest way to do this is stand on the visual draft mark, as you would actually always stand on the forward visual draft in front of the visual draft marks for taking the draft readings. Here also for our assumption, we stand in front of that. Now, once that is done, look at the location of the forward perpendicular from your visual draft marks. So now in this case, if the visual draft marks is located after the forward perpendicular, or we can say inversely, we can say that the forward perpendicular is forward of the visual draft mark. In this case, we have a stern trim. So you can see over here, both are opposite. That is stern trim, that is towards the stern, and the forward perpendicular forward. So as the names are opposite, we apply the minus sign. So again, in this case, the forward perpendicular is forward of the visual mark, whereas the trim is stern. Because the names are opposite, the correction is negative. So this is how we apply the corrections, the signage for the perpendicular correction. Let's look at another example. This is the aft of the ship, the stern of the ship. This is the visual aft visual draft marks, and this is the aft perpendicular draft marks. So like exactly what we did in the forward, we stand in front of the visual draft marks. From here, look at the location of the aft perpendicular. So here I can see the aft perpendicular is located towards the aft of the ship. The stern is, the trim is also aft stern trim. That means both are of the same sign, both are of the same thing. That is why both are the same value. So the correction is plus in this case. So this is how we apply the corrections for the perpendicular corrections. Now, once we have the signage, it's just a simple addition subtraction with the visual drafts. So the visual draft plus or minus the forward correction will get us a forward draft at the perpendiculars. Remember, now we are coming to the perpendiculars. The midship perpendicular draft, it will be the visual draft, visual midship draft, that is, plus or minus the midship correction. And the aft perpendicular drafts will be the visual drafts, aft draft, plus or minus the aft correction. So once we do that, we will be getting the drafts at the perpendiculars. And please remember, once we have the drafts at the perpendiculars, we always stick to this draft for all our further calculations and references. But always remember, there is always an exceptions, as always. When we come to the list correction towards the end, we will be using the visual draft marks again. So that is only one time when we use the visual draft marks again after the completion, once we find out the perpendicular drafts. Otherwise, for all our normal calculations, we'll be using the drafts at the perpendiculars only. So now once we have the drafts at the perpendiculars, let us go ahead with the corrections. The second correction which we apply is a correction for hull deformation. The drafts and the perpendiculars will have to be corrected for hull deformation, that is basically hog and sag of the vessel. Depending upon the loaded state, depending upon the conditions of the vessel would be having either hog or a sag. Now, this is done by obtaining what is called as a mean of means, also known as quarter mean draft. And the formula is pretty simple. The mean of mean drafts is in the numerator, we have forward draft plus the aft draft plus 6 times the midship draft. And the whole thing is divided by 8. So this is basically what is called as a mean of mean drafts. And the calculation is also pretty simple. This forward draft, aft draft, and the midship drafts are all the drafts at the perpendiculars. Like we discussed earlier, once we have the perpendicular drafts, we don't go to the visual drafts anymore. The mean of mean or the quarter mean drafts can be taken as an approximate draft of the vessel at the midship, which allowing it for the hull deformation, that is hog and sag. But this is not really what we need. So we go to the next correction, what is called as a first trim correction. And the main reason for that is because the mean of mean draft or the quarter mean draft, what we have found out in the previous step, is only an approximate midship draft. Remember, we want the hydrostatic draft. So for the finding of the displacement of the vessel, what we require is a hydrostatic draft, or in other words, the draft at the center of flotation of the water plane in which the ship is presently floating in. The correction which is applied to the mean of mean drafts to obtain the hydrostatic draft is called as a first trim correction. And the formula is given out here. The first trim correction is in the numerator, trim multiplied by half of LBP minus LCF. And in the denominator, we have LBP. This is again length between the perpendiculars, because again, we are going to use all. Even the trim value is also between the perpendiculars. And this LCF value is a value of the, this LCF, what we see over here in the numerator, that is a value of at the mean of mean drafts. From the stability particulars, we can take it out and we can get it. So again, the first trim correction is trim multiplied by half of LBP minus LCF whole divided by LBP, and the value what we get is in meters. Okay, again, the trim is trim between the perpendiculars. LBP is what is given already for us, and LCF is a value at the mean of mean drafts. Now, again, we have to decide the sign of this first trim correction. So if you look at this the formula very carefully, the LBP by 2 minus LCF is the one which decides the sign of this particular answer. The trim is a static quantity which is always obtained from the numerical, and the LBP is also a static entity. So basically, the LBP by 2 minus LCF is the one which decides the sign of the first trim correction. Now, what we suggest is just retain the same value as it is. Whatever answer you get, that will be taking care of the whatever sign, whatever answers you get over here, that can be retained in the normal conditions. In the normal conditions, we'll be having some stern trim. So maintain the same sign as the above result. If for some reason in the numericals or in the actual conditions, you're down by head, then whatever answer we get over here, the sign is reversed. So if you get a plus value, then you put it as a minus value. If you get a minus value, then a plus value. In case you have a stern trim, maintain the same sign as whatever you get over here. So don't change the location of this LBP by 2 minus LCF. Just retain it as it is given in this formula. Once we get the first trim correction, you have to add that to the mean of mean drafts, and we get what is called as a true mean draft. Okay, so the mean of mean drafts obtained from the step 3B previously, and add or subtract based on the sign the first trim correction, which is obtained in the step 3C. The next what we have to do is we have to find out the true mean displacement, or it's called as a TMD. So obtaining the displacement from the hydrostatic particulars. So whatever answer we get the true mean draft, we have to obtain the displacement from the hydrostatic particulars. There is also one more correction to be applied, that is called as a second trim correction, that is basically taking into account the trim of the ship. The LCF what we obtained earlier is basically from the hydrostatic tables, which is in turn built for even keel condition. But actual LCF of the ship, the actual location of the LCF, will also depend upon the trim of the vessel. As the trim changes, the water plane area also changes and the location of LCF also changes. So the STC, the second trim correction, corrects this small shift of LCF due to the existing trim of the vessel. So that small correction what is applied is called as a second trim correction. And the formula goes like this: second trim correction is equal to 50 times the trim square. Again, this is a trim between the perpendicular into a difference of MCTC1 and MCTC2. Now, MCTC1 and 2 is the difference between MCTCs 50 centimeters above and below the mean of mean drafts. So if the mean of mean draft is, let us say, 10 meters, then we take it as 50 centimeters above, that is 10.5, and 50 centimeters below, that is 9.5. So the values for the MCTCs can be obtained from the hydrostatic particulars, and that can be put in over here, and this whole thing divided by LBP. And the answer what we get is in tons. So again, the second trim correction is equal to 50 times trim square. The trim is the trim between the perpendiculars. MCTC1 and MCTC2 here are the difference between the MCTCs 50 centimeters above and 50 centimeters below the mean of mean drafts. Now this entity will always be positive value. That means when you are going to calculate the MCTC1 and 2, always subtract the higher value from the lower value and put the sign. There is no negative sign over here because the value will always be positive only here. So this value what you get from here is always a positive entity, and it is always added to the true mean draft displacement what we obtained in step 3E earlier. Once we do that, we come on to the next correction, which is called as a list correction. As you all know, the list also changes the water plane area of the ship, and there is also small correction to be applied to take into account this change of water plane area. In general, for small size ships, this is not taken up, this is disregarded, because the value of this list correction obtained is very, very small. But however, for the examination purpose, we have to take into account, because this is also a step for the final answer. So for the MMD examinations, for DGS examinations, this correction has to be applied if it is given in the numerical. Now, let me tell you beforehand the list correction. I mean, the first thing what we ensure that is a ship is perfectly in an upright condition. If you have a ship which is perfectly upright, then this list correction doesn't apply at all. But however, in the numericals, if there is some list given, then we have to apply this list correction. The list correction formula goes like this. It is 6 times the difference between midship draft, that is visual draft, port side, and the visual draft starboard side midship. This multiplied by the difference of TPC for the visual port and TPC for the visual starboard. Now, please remember, list correction is one exception where we again go and use the midship draft, and that too the visual draft. Rest all the corrections what we have applied earlier was all for drafts of the perpendiculars, whereas here the list correction we have to use the visual drafts for the midships. So again, this MD VP minus MD VS. Again, the sign is it's always a positive sign. So always subtract the larger value from the smaller value. Here also TPC is always the larger value subtracted from the smaller value. The net result is an absolute answer, which is always in positive value. So TPC VP is basically the TPC from the hydrostatic tables of the visual port side draft mark and the TPC value obtained of the visual starboard side draft marks. The answer what we get from this formula, the correction is always in tons and it is always positive. That means it's an additive correction. So this additive correction, this list correction is added up to the displacement what we found earlier, that is the true mean draft displacement. We add up the STC, the second trim correction, and the list correction, and we come on to what is called as the final displacement of the ship. But remember, the hydrostatic tables are given, the values are given for salt water. So the displacement what we obtain is also for the salt water displacement. Now, depending upon the ship's density, depending upon the density in which the ship is floating on, you will have to apply the salt water, the density correction. Okay. If the ship is floating in any other density, that is like dock water, we have to apply the density correction. The density correction is very simple. the corrected displacement of the ship, that is the final actual displacement of the ship, is the displacement in salt water divided by the density of the salt water and the whole thing multiplied by the density of the dock water. Now, a very simple way to remember this, because most of the time what happens is you will get confused between the density of the dock water should go in the denominator or the numerator. The easiest way to understand this one is we have in hand our displacement in salt water. That is what we obtained from the previous example. Now I want to change over to the displacement in dock water. So we are changing over to dock water. So the dock water always comes in the numerator. What we are leaving behind, that is the salt water, the density of the salt water always comes in the denominator. So again, the correction for displacement, that is a corrected displacement in the dock water, is the displacement in salt water multiplied by the density of the water where you want to go to, that is in this case, dock water density, divided by the density of the water, what you're leaving behind, that is a salt water. Okay, the density of salt water, as we know, is always 1.025. So you can use that figure also directly and get the answers out. So this is the final corrected displacement of the vessel for the in case the density is different from salt water. Now that is the final displacement what we need. Now let us do this whole thing. Let's work it out using an example. So in this particular example, we are going to take the values from MV Hinship, the stability particulars, what you are going to use in your examinations also. And we have to find out the displacement of MV Hinship in a dock water density of 1.012, where the given drafts are, the forward is 7.01 meter, midship port side is 7.71, midship starboard side is 7.85, and the aft is 8.53 meters. Now these are all visual draft marks. In the numerical, there'll always be a kind of, the distances from the visual draft mark to the forward perpendicular will always be given. So whatever value comes here, we have to take the value as it is. The forward visual draft marks is 3 meters after the forward perpendicular. That is forward perpendicular, the forward of the ship, and this visual draft marks is 3 meters after. Midship visual draft is 2 meters after the midship perpendicular. That's also okay. But if you look at this last line over here, I'm giving the aft perpendicular with respect to the visual mark. So please remember, don't take it directly from here. Read, understand what is given over there. So in this case, after perpendicular is 4.5 meters after the aft visual mark. That means the visual mark is forward to the aft perpendicular. So please read this English carefully and understand the location of it. And like any other numerical, the first thing is draw a diagram that clears you exactly the location of what is where, so that there won't be any confusions also when you're going to be doing this exam in the exams. So you draw a simple, like a kind of a diagram which denotes the location of all these, the location of the visual draft mark with respect to their respective perpendiculars. So now in this case, we have the visual draft mark, which is 3 meters aft of the forward perpendicular. The visual mark is 2 meters after the midship perpendicular. So the red line is a perpendicular and the green line is a visual. And the last line is aft perpendicular is 4.5 meters aft of the visual marks. That means with reference to visual mark, aft perpendicular is 4.5 meters aft. Now this 3 meters is A, 2 meters is B, and C is the 4.5 meters. Once we have this, we know the distance between the aft perpendicular and the forward perpendicular as LBP of MV Hinship. If you subtract 3 meters and 4.5 from there, we will get the distance between the draft marks. So the length between perpendicular of MV Hinship is 143.16. 143.16 minus 4.5 minus 3 meters, we will get this answer of 135.66. So now we have all the values what is required for finding out the perpendicular corrections. So let's get on with that. The TB, that is the trim visual, is 1.52 meters aft. That is the 7.01. Sorry, 8.53 minus 7.01 is 1.52. LB, that is the distance between the visual draft marks, is 135.66. Again, how did we get this? It's a subtraction of the length between the perpendiculars minus 3 meters minus 4.5 meters. That is basically, I want this AB to FB. And the ABC distances as we have obtained it from here. So when you do the calculation using this formula, TV by LB multiplied by A TB by LB, remember, is a factor which will always be used for all the other corrections also. So what I suggest is note down this value and use the same value for your future calculations. So this multiplied by 3, and the answer what we get is 0.034. And now why is the sign minus? The sign is minus because if I'm going to stand in front of the visual draft mark, the perpendicular is located forward and the vessel is trimmed towards the stern. That is the reason why the sign, it's forward, the location is forward, and the trim is aft. Signs are opposite, that is why negative sign. Similarly, we will be doing it for midship also and for this aft also. So the midship is minus 0.022. Why minus is because the same answer is the same logic as what we had minus sign for the forward correction. Because here the midship draft mark is forward, the midship perpendicular is forward, and the stern trim. So it's an opposite sides, that is why negative. Whereas in the aft perpendicular is aft and the trim is also aft. That is why positive. So we have these answers minus 0.034, minus 0.022, and plus 0.050. Once we get this, add it up to the visual marks, and then you can get it. For the midship draft, you can take the mean of the port side and starboard side. So mean of the midship draft, the port and starboard, is 7.78. That minus 0.022, and the midship draft at the perpendiculars would be 7.758. So using this, now we have to use only these drafts for all our future calculations. Remember, except for the list correction, where the visual drafts are used. Next, we come to the correction for hull deformation, because to negate the effects of hog and sag. Again, the formula is used as forward draft, aft draft, and 6 times the midship draft, and these will be the draft at the perpendiculars. So this was obtained from the previous exam, from the previous step. So this is just for recollection, and the values are out here. So forward draft 6.976. So we just copy down these values, and remember 6 times the midship draft and the whole divided by 8. We got 6.976 plus 8.58 aft draft, and 6 times 7.758. That is equal to 62.104. That's the numerator. Divide that by 8, and we get the mean of mean drafts, that is 7.763. Now this is a draft, approximate draft at the midship of the vessel. But remember, we don't want the midship of the vessel, we want it at the longitudinal center of flotation. So we come to the first trim correction, and the formula for that is trim multiplied by half of LBP minus LCF. This LCF is a LCF of the mean of mean drafts, which we got it from the previous step. So we have all these known values. The trim is also known to us. That is the visual, the trim at the perpendiculars. The mean of mean drafts also known to us. Now the LCF for the mean of mean drafts is obtained from the hydrostatic particulars, hydrostatic tables, and that is 70.817. So we are going to use these values to obtain our first trim correction. So 6.104, that is, 1.604, that is the trim of the vessel, and half of LBP is 71.58, minus LCF is 70.817, and we get the answer as 0.009. However small the answer is, we still have to kind of respect the answers, and we just carry forward the same thing. Because the ship has got a stern trim, we just retain whatever value of the answers what we get out here. So the same as the plus sign. Do not change this entity LCF and LBP by 2. Just let it be like this only. Don't please change that. Now to obtain the true mean draft, we have to add this first trim correction to the mean of mean drafts. So the true mean draft is equal to 7.763 plus 0.009, and that comes to 7.772. That's our true mean draft. Now the displacement for this true mean draft, the displacement in salt water, that is, because it's being obtained from the hydrostatic particulars, which is meant for salt water, that is 16095.480. So now we have the true mean draft displacement for the salt water. Now we come to the second trim correction. Second trim correction formula reads as 50 times trim square and the difference of MCTC 1, MCTC 2. So we have the MCTC, The difference is out here. So we can obtain the values. For trim of 1.604, MCTC1 is 7 for a draft of 7.263, that is 187.219. MCTC2 is for a draft of 8.263, and that is 201.114. Now this is 50 centimeters plus and minus. That is, we have the mean of mean draft 7.763. 50 centimeters less is 7.263. 50 centimeter plus for this is 8.263. So now we have the MCTCs, and now we can put these values into our calculations and obtain the answer. And the answer what we get is plus 12.486. Now, as we discussed earlier, the second trim correction is always an positive sign. Now, if you look at the numericals, the midship draft marks were not same. The port was different from the starboard, and that is because the vessel has got a list. So now we are going to apply the list correction. So midship draft, the visual draft marks was 7.85, and the visual starboard draft mark was 7.71. So now we are going to apply the corrections to get it. And this MDVP, that is midship draft, visual, port side, the difference of the draft marks, that is 7.85 minus 7.71. Remember, this answer is always in positive entity, the absolute value, that is 0.014 meter. The same thing applies for TPC also. The TPC of the port side visual draft mark and the TPC of the starboard side visual draft mark. The difference is obtained. The difference is again the absolute value, and it's 0.087 tons. Once you replace these values in the formula, then we get 6 times 0.14 multiplied by 0.087, and the answer is 0.073 tons. This is also always positive. That means we are going to keep it in the plus sign only. Ultimately, we get the final displacement in salt water, which is equal to the true mean draft displacement, what we got earlier, plus the second trim correction and the list correction. So the final actual displacement of the vessel, and the displacement of the vessel in salt water is 16108.039 metric tons. The story is still not finished. The ship is not in salt water, the ship is in the dock water. So now we have to apply the density correction. Now the formula for that is again the corrected density, the corrected displacement of the vessel in dock water is a displacement in salt water, what we got in the previous step. In the numerator, we will have the density of the dock water where we are going to, that is in this case 1.012. In the denominator, we will be dividing it with the density of the salt water, what we are leaving behind. So 1.025. So when you put this into the formula, then we get this answer as 15903.742. This is a displacement of the vessel. So 15903 is a final answer, and decimal 742 is a final answer for this numerical. All right, as a recap, what we have just seen is the various terms and definitions used in the draft survey. We've also seen the draft survey and its objective as to why we do go about doing it. We've also seen the steps in draft survey to obtain the displacement in salt water. And ultimately, in case a ship has got some list correction or the density correction, we've also seen how to apply those corrections and get it to the final density, the final displacement at the density in which the ship is floating in. Once this displacement is obtained, it can be used to calculate the weight of the cargo and all the other calculations. This is also used for calculating the amount of cargo which is to be loaded or discharged in compliance with various load line regulations and draft restrictions, and also allowing for the hog and sack. Now, those calculations, how we go about doing it is generally will be taken up in another video. And what we have seen just now is how to calculate the displacement of the ship. I hope you enjoyed watching this video. If you have any queries, if you have any doubts, please feel free to post your comments. And thank you very much. Thank you very much for watching this video.